We're given an equation here, and we're told to find the length of the longest axis of this ellipse. So first of all, before I get into any of the math, let's just go over why this equation here is the equation for an ellipse. So the reason why is because we have this 9 in front of the x squared and this 4 in front of the y squared. Because if you think about it, the equation of a circle is x minus h squared plus y minus k squared is equal to r squared. So in this case, your x squared term would never, the coefficient would always be a 1. You would never have something like 9x squared. In the y squared term, your coefficient would always be a 1. So we know that it's not a circle, and we have 9x squared plus y squared. So we have x squared positive and y squared positive. So we know, since it's not a circle, it must be an ellipse. So now let's find the length of the longest axis. So in order to do this, we have to manipulate this equation that they give us up here to get the standard form of the equation for an ellipse. So the standard form is, as we went over before, it's x minus h over a squared plus y minus k over b squared is equal to r squared. So basically we have to figure out a way to complete the square to get x minus something squared and go from there. So first, before we do anything, let's factor out a 9. Because if we want to complete the square, we have to have x squared just by itself. So in that case, we have 9 times x squared minus 2x. Let's do the same thing for this 4y squared and 16y here. Plus 4 times y squared plus 4y. And all that is equal to 11. Okay, so at this point, since we have x squared minus 2x, we know that we can complete the square to make that x minus 1 squared. So x minus 1 squared is the same thing as x squared minus 2x plus 1. But we have an x squared minus 2x here, so that's what we want to have. So let's subtract 1 from both sides of this equation here. In that case, we get x minus 1 squared minus 1 is equal to x squared minus 2x. So all I did was just subtract 1 to both sides. So now we can take this. This is x squared minus 2x, and that's the same as that. So basically, we can plug this x minus 1 squared minus 1 in for x squared minus 2x up here. So I'm going to go back. Oh, and also we can do the same thing for y squared plus 4y. So, hold on. First of all, I'll do it for the x squared minus 2x. Okay, so we can rewrite this as 9 times x minus 1 squared minus 1. And for the y squared plus 4y, we would do the same thing. We'd want to factor out a y plus 2 squared, because this is 4, so you would just have it for 2. So you'd factor that out. Y plus 2 squared is equal to, so let's just multiply this out first, is equal to y squared plus 4y plus 4. And notice, currently, this y squared plus 4y plus 4 is not the same as this y squared plus 4y. So we want to subtract 4 from both sides of this equation to make them the same. So y plus 2 squared minus 4 is equal to y squared plus 4y. Now, since we know that these two are equal, we can substitute this right here in for y squared plus 4y. So I'm going to do that really quick, and then we'll keep going. I know it's really annoying that I'm like erasing all this stuff, but I can't really scroll down, so sorry about that. Okay, so this is the same as 4 times y plus 2 squared minus 4. And all this is equal to 11. Okay, I just want to make sure I did it right. Y squared plus 4y plus 4. Okay, yeah. So now we've done part of what we have to do. So now we have this minus 1 here, which we don't really need. So let's just multiply everything out for now. We have 9 times x minus 1 squared minus 9 plus 4 times y plus 2 squared minus 16. And all that is equal to 11. So now, in order to get rid of this negative 9 and negative 16, we can add negative 9 to both sides. So if we add negative 9 to both sides, or add 9 to both sides, and then these would cancel out. And we can also add 16 to both sides. And then those would cancel out. So we added 16 to both sides and added 9 to both sides. And now we have 9 times x minus 1 squared plus 4 times y plus 2 squared is equal to 11 plus 9 plus 16, which is also 36. So since I'm running out of room, I'm going to have to erase everything and then write it up on top. So yeah. So we have 9 times x minus 1 squared plus, hold on. Jeez. 9 times x minus 1 squared plus 4 times y plus 2 squared. Plus 4 times y plus 2 squared. And all of that was equal to 36. Once again, I'm sorry that I have to erase everything. I just don't have any more room. Okay, so now, let's remember that for the general form of an ellipse, we have x minus h over a squared plus y minus k over b squared is equal to 1. So right now we have 36, and we want to divide by 36 to both sides of this equation to get everything equal, to get this thing here equal to 1. So let's do that. Okay. So if we divide by 36 to both sides of the equation, we get 9 times x minus 1 squared over 36 plus 4 times y plus 2 squared over 36 is equal to 1. And we can simplify this a little bit, because if we divide by 9 to top and bottom, this would become 1. 36 divided by 9 becomes 4. We just divided by 9 to both sides, or to top and bottom. And in this case, if we divide by 4 to the top and divide by 4 to the bottom, 4 divided by 4 would cancel out to become 1, and 36 divided by 4 would be 9. So now we have x minus 1 squared over 4 plus y plus 2 squared over 9 is equal to 1. But for the equation of an ellipse, we have x minus h over a squared plus blah blah blah. So basically, we have to get this thing on the bottom. We have to get it inside the parentheses. So what we can do is we know that 4 is equal to 2 squared. So let's just rewrite this really quick. So x minus 1 squared is equal to, or all this is equal to x minus 1 squared over 2 squared plus y plus 2 squared over 3 squared is equal to 1. And since we have x minus 1 squared over 2 squared, that is the same thing as x minus 1 squared, x minus 1 over 2 squared, plus y plus 2 over 3 squared, and all that is equal to 1. So this right here would be the general form of the equation for the ellipse, and if you're trying to find the length of the longest axis, since this 3 right here, so basically it would look like this. You'd have the center would be at the point 1, comma, negative 2, and then you'd go, the major axis would be 3 higher than your center, and then the bottom would be 3 lower than the center, and it would be something like this. So the length of your major axis is 3 plus 3, which is 6. Okay. And I just want to go over what I did over here, like x minus 1 squared over 2 squared, and how I got that to this. So I'm going to erase everything and then show you. So I had in the beginning x minus 1 squared over 2 squared. And that's the same thing as x minus 1 over 2 squared. Because if you think about it, x minus 1 over 2 squared is the same as just x minus 1 over 2 times x minus 1 over 2. And if you multiply this together, you would get x minus 1 squared over 2 squared. So that's why we know that these two things are the same.